It saves us time and money, and it's convenient. So depending on the population, it actually can be a pretty valid way to sample. So again, when we have a stratified sample, we're taking some from every different type of category. We base the strata on having similar characteristics. I don't know what these big dots are, sorry. And then when we cluster, we take all from some. So based on, again, locations of individuals. So clusters don't necessarily reduce variability. They don't reduce the spread like stratification does. And bias samples, excuse me, are still possible, which means you're not necessarily getting a good representation of the population. So, I mean, I don't know. Here's an example. So we've got a good read. So a school librarian wants to know the average number of pages in all the books in the library. So this might be a good like detention question or something. Like she could have everybody go around and do this. But instead, she doesn't want to do that. So the library has about 20,000 books. Each is arranged by type. So fiction, biography, history, so on in the shelves. And each shelf holds about 50 books each. So explain how to select a simple random sample of 500 books. So you could pause right here, talk with somebody, see what you come up with. I know you can kind of see the writing there, but see if you come up with something. And then once you've done that, okay, so you could assign all the books a number from 1 to 20,000. You could use a random number generator to select 500 unique books, meaning that we would, anytime we got a repeat, we would toss that one out, okay? So you probably would not do this on your calculator. So that website that we used the other day, Randomizer, would be a good one because you can specify in a website like that or in your computer that you do not want any repeats. So you want all unique values. And then you would sample the books corresponding to these numbers. So you'd have your 500 books. You would go to each book that was chosen. You would look at see how many pages it had. So still kind of time consuming because it's 500, but obviously a lot less work than all 20,000. Okay, the next thing you could do is you could select a stratified random sample. So again, you can pause here and talk with somebody and then see what you come up with. Excuse me as I yawn. Okay, so in this case, you might stratify by genre. So again, like maybe different books have different lengths. Like maybe, young adult books are on average shorter than historical fiction books or something. This is a good example of, all fiction books being somewhat similar between themselves, but being different from like research books, something like that. So that's what we were talking about earlier when I said they would be similar within, but different between. So all works of fiction maybe have some similarities, and that would be different than if you compare them to some other genre. So then you would take a simple random sample of each strata to get 500 divided by how many genres there were. So let's say the library has 10 genres, okay? Then you would do 50 divided by 10. Sorry, 500 divided by 10 would be 50. So then from each genre you would pick 50 books, okay? And that's how you would do that. Okay, then the last one would be explain how to select a cluster sample of 500 books and explain your choice of cluster and one reason why this method might be chosen. So if you want to pause, go ahead. Otherwise, my cat's going crazy, sorry. So if there's 500 books on the shelf, like they told us in the intro, 20,000 divided by 500 is 400 shelves. So then we could cluster by shelves, and we would label the shelves 1 to 400. And then you could randomly select 10 shelves. You would do random integer 1 to 400 repeatedly until you get 10 unique shelves. And then with those 10 shelves, you would sample all of the books on the selected shelves. Okay. So all of these have their drawbacks. Nothing is going to be perfect. Okay. If you take a simple random sample, that would be time consuming. You're going to get books all over the library, so you're going to have to travel all over the library to get them. And it doesn't necessarily ensure that you're getting some of each type. So you might do a simple random sample and maybe no research books come up, and so you're missing all of those lengthier books. With the stratified sample, there might not be equal proportions of genres. So I think I said we would take 10 of each genre, or 50 of each genre, maybe was what I said. But if, there's much less of one type of genre, then you're going to get an overrepresentation of that genre if you're taking the same amount of that as some other genre that there is more of in the library. And then in the cluster sample, you might get all of the same genre. So, if you end up getting, shelves that are right next to each other and you're doing all of those books on those shelves, then that might be 3 shelves of biographies, and those might be different than other books in the library. So, that gives you less variation in the type of genre that you're getting, possibly. All of these sampling methods are ways that we can take a sample so that we can then make guesses about the true proportion in the population of whatever it is that we're sampling. Okay, so again, with the books one, whichever method that we use, what we're doing is we're taking a sample that we're trying to take in a way that's representative of the whole entire library, and use that sample to say, well, in our sample, the average book page was 247.2. So we're going to try to make a guess then about the average book length of all of the books in the library, which would be the population. So that's the whole point of this. We don't really get to inference in this class until the last quarter of the class, but in this chapter, what we're talking about is how to design a statistical survey so that we get valid results that we then can make an inference about. Okay, so there's one last activity that I think we're just going to have to do this activity actually when I get back on Tuesday. So just leave this blank and we'll do that on Tuesday. Okay, so, I think we're almost done. Okay, I'm not making you dizzy with this. So the margin of error. The margin of error is how far you can be on either side of the truth and still be statistically correct. So you hear this all the time when they're talking about polls with elections and stuff, is the most common place that you hear this. Okay, it is not a mistake. It's not saying that we made a mistake in our sampling or we made a mistake in counting or anything like that. It's just saying, obviously, when you take a sample, you're not necessarily going to get the exact true population mean or whatever parameter you're studying. So we're saying, we think, so we're saying, these are results plus or minus, this little bit. So the larger the margin of error, the less meaningful your results are. If you increase your sample size, so the bigger the sample size you take, the closer you're going to get to the truth. Okay? It's going to decrease variability, and that would be really desirable. So, if you think about this, if you want to if you want to take a survey of Mayfield senior school students to find how, on average, how much time they spend on homework. If you ask 3 people, that's probably not going to be that representative of the whole entire 330 students or whatever it is, okay? But if you ask 50 students and you sampled properly, then you would be much more likely to get a better representation of the population. And if you asked 100 students, you'd have, even better representation of the population, again, as long as you sampled properly. So statisticians have to find that sweet spot where they're asking enough people that they're getting valid results and it's fairly representative of the population, but it's not too time consuming and too expensive, because otherwise just ask everybody, right? But we don't do that because it's just going to take too much time. People aren't going to want to answer our questions, that kind of stuff. Okay, sampling frame. You had this already in your notes, I think, but it's just a list of the individuals from which a sample will be drawn. Sometimes it's a population, most of the times it's not, because again, you don't normally have a list of all of the residents of the United States of America. That's just too many people. Undercoverage can occur when some members of a population can't be chosen in a sample. So, for example, there's an article on the topics page that it says a recent poll, so it's now a year old, that used landlines to get survey results. But, I mean, most young people don't have landlines. Like, most people have cell phones these days, right? So young people were undercovered, and so it really, it got election results really wrong in one of the primaries in the last election. So undercoverage is, some people can't be chosen in a sample. So you have to think about that when you are designing your statistical sampling method. And it's going to lead to bias because you're leaving out basically a whole group of population. Non-response is when somebody gets chosen for a sample and they can't be contacted, or they just refuse to participate. So, you get a survey in your email from, Lululemon asking you about whether or not you need tighter leggings, and you just delete the email. Okay, so that's non-response. Again, this is going to lead to bias because most of the time, the people that are going to respond are people that have very strong opinions, and so it's going to end up being that people that are a little more moderate don't get their opinions heard. Non-response is different from voluntary response in that non-response happens after the sample is selected. Okay, so voluntary response we talked about with that Lou Dobbs example where he said, hey, I have this poll on my website, go do it if you want. Whereas non-response would be Lou Dobbs sent all of his viewers somehow an email, and then some people just chose to reply and some people chose to not reply. So here's just a little review of voluntary response. Again, I don't know what those dots are. Okay, and then response bias. So this is a systematic pattern of inaccurate answers due to gender, race, age, ethnicity, or behavior of the interviewer, the person asking the questions. So remember in the last class, I said if we took a survey of students who love math, right? Well, if I'm the person that's asking that question and I'm asking it face to face to you, because of the fact that I'm your math teacher, you might lie, right? I mean, why would you say to my face, I hate math? That would not be very nice. So, because of my, not necessarily any of these things, but because of my role as a math teacher, you might feel like you can't tell me the truth, okay? it has something to do with